Welcome, everyone, to the second in our hazardous waste regulation update series. We're really glad that you're able to join us here today. Today's focus is going to be looking at the hazardous waste requirements from the lens of the printing industry, as well as we'll have a great discussion on hazardous waste determinations and land disposal restriction requirements. The program today is brought to you by this whole host of organizations that have been working together through the Wisconsin Printing Industry Council to bring resources to the printing industry, not only programs such as this, but also working on other outreach efforts as well as in-depth regulatory issues that directly impact the printing industry. We're hosted today by Joe Lyman with the Great Lakes Graphics Association. Joe, thank you again for hosting our program, and he will be bringing to our attention your questions as we go through the program. So my name is Marcy Kinter, and I'm the Vice President of Government and Regulatory Affairs for the Printing United Alliance, and I will be with you today as we go through the program on hazardous waste determinations and land disposal restrictions. But a few notes. So all attendees are muted. If you do have a question, unlike this screen, the chat box for Zoom is at the bottom. So please go ahead and put your question in the chat box at any time. And as we like to say, there's no such thing as a silly question. Ask any question, and if hopefully we can get to all of them at the end of the program, but if not, we will go ahead and reach out to you following the conclusion of our recorded program. And we are recording, and everything will be sent to you in a follow-up email. So as I mentioned, this is the second of our 6 series in the hazardous waste overview, and we kicked off our sessions in December 3rd on introduction and common violations, and the link to the recorded program can be found in the chat box, and I encourage you to download that link and go ahead and take a look. It was a great program that provided just so much information on the changes that have happened within the hazardous waste regulations, as well as taking a look at some of those common violations that the printing industry is experiencing. So I encourage you to take a look at that program. And again, if you have any questions, reach out to us. We're here to help. But today we're focusing on the waste determinations and land disposal restrictions, as well as taking a look at the hazardous waste requirements through the lens of the printing industry. So I'm really excited to introduce our speakers today. First, we have my colleague, Gary Jones, who's the Director of Environmental Health and Safety Affairs for the Printing United Alliance. The Printing United Alliance is the largest member-based printing organization, and Gary has over 30 years of experience in helping facilities both understand their regulatory requirements as well as working with those agencies that are developing those programs. And I have to say, I think I've been working with him for most of those 30 years. We also am really excited that we have Mike Ellenbecker with us. He began his career as a hazardous waste inspector in 1990, and he visited over 1,600 facilities. Then in 2010, he became the department's hazardous waste plan review specialist. And as that, he was responsible for reviewing plan modifications and relicensing applications for Wisconsin's 12 treatment, storage, and disposal facilities. And then in 2013, he became the Hazardous Waste Program Coordinator. And he's responsible for, among many other things, developing guidance and policy on hazardous waste issues, which is, I think, one of the reasons why he is joining us here today. So we're really excited to have both of you here to present this information. And with that, I turn that over to you, Gary.
Well, thank you, Marcy. Good afternoon, everyone. As Marcy mentioned, Mike and I are tag teaming with today's presentation. I'm going to cover the beginning part. We're actually going to look through common waste for printing operations and how they're classified. For those of you that sat in on our session 1, we started with an introduction of what constitutes a solid waste, which I know I had mentioned is probably one of the most convoluted and complex definitions I've ever read in any regulatory program. And Mike's going to follow up and touch upon some of those items that we talked about in the first session regarding, what is a solid waste, and because it has to be a solid waste before it's regulated as a hazardous waste. And then I'm going to talk about common issues with vendors and share with you a story that we just recently concluded with a member who ran into some issues with how their waste was actually classified. So we'll use that to illustrate, I think, a couple very important points in terms of your responsibility, but primarily your responsibility as a generator and what you need to be doing with respect to understanding and classifying your particular waste streams. Next slide, Marcy, please. Okay, so what I thought probably the best way to handle this and looking at the different, and I would say probably common waste streams that are generated by a variety of printing operations. I know that we probably have folks on the line that utilize more than just one type of printing operation or one type of printing technology, conventional as well as digital. What I thought I'd do is I have a couple slides with some charts of common waste streams, and I want to talk about where they fall relative to the classification of it being a hazardous waste. One thing about the charts, you'll see that obviously we identify the waste stream, identify if it's hazardous, why it's hazardous, if it is hazardous, and then on the far right-hand side, you'll see a waste code. Now, in the world of hazardous waste, these waste codes become very important because it becomes basically the best way would be a universal nomenclature system by which different types of hazardous waste streams are identified. So the waste code, and Mike's going to go through the waste codes a little bit more in detail, but the waste code is very important because that's what's going to get put on your manifest, for example, for your hazardous waste manifest. And as we talked about with some of the changes with the hazardous waste regulations, in addition to just putting on the label on your container that you're using to collect the hazardous waste, you now need to put the words hazardous waste and then some type of indication as to why or what type of hazardous waste, and you could very easily put the waste code on there. So waste codes are becoming more and more important in terms of how we utilize them with respect to labeling, but we will definitely need those on our manifest, and also when you do a notification of hazardous waste activity to EPA to let them know that you're generating hazardous waste, you need an ID number, you need to list your waste codes there as well. So these waste codes do become very important with respect to your hazardous waste. So let's start at the top, and obviously ink. Ink is a very common waste. And if we have uncontaminated lithographic, screen, and water-based inks, typically those inks themselves are not going to be hazardous waste because they don't exhibit any characteristic or are contained or would qualify as a listed hazardous waste. And Mike's going to talk about characteristic and listed hazardous waste. I do have one thing to point out is that some red inks can contain barium because of the pigment, and typically those are going to be more in the warm red category. And there is a threshold for barium, which if you exceed that threshold for the concentration of barium, it would be considered a hazardous waste and carry the waste code D006. Now, the best thing to do in terms of understanding that, again, it's just some of the reds, is to go back to the ink vendor, believe it or not, go back to the ink vendor and ask them if they have data that would indicate if the red ink that you're using would actually pass what's called the toxicity characteristic leaching procedure, TCLP. Again, Mike's going to talk us through what that really means. But barium could be an issue because of the red. Typically, it's not common, but we did want to put that out there because it can sometimes show up as a hazardous waste. Now, obviously, if I have a solvent-based ink or other ink mixtures with solvents, primarily if I have ink in a solvent mixture, like for cleaning off presses, for example, off litho presses, if I have my cleanup tray, if the predominant component of that's going to be solvent, typically that's going to be a hazardous waste, and generally because the flash point's below 140 degrees Fahrenheit, and that'll get the waste code D001. Obviously, cleaning solvents and chemicals such as blanket washes and roller washes, cleanup solvents, and inkjet inks, for example. A lot of solvent-based inkjet inks also going to flash below 140, and that carries the D001 waste code. Solvent-contaminated wipes. Now, very interesting. We worked with EPA many years which ultimately resulted in a culmination of a federal regulation on solvent contaminated wipes that addresses both disposable and reusable wipes. And the good news is that as long as they're properly managed, both reusable and disposable wipes, those are not considered hazardous waste. In fact, the reusable, which are the laundered wipes, aren't even considered a solid waste, as long as you send them off-site for cleaning, and most importantly, you're managing them properly. Proper management, and there's a fact sheet on this. There's a lot of information we're going to cover in an upcoming session, but quickly, they can't be saturated. In other words, they have to pass what's called the paint filter test. They have to be kept in a closed container. The container must be labeled, and when you send them off-site, they have to be in a sealed container. So there's a whole a short list of things that you have to do, as well as record keeping, to show that they're being properly managed. And if you have that, then you're going to be able to basically throw away reusable disposable wipes and send the reusables off-site for laundering, and they're not going to be considered a hazardous waste. Next slide, please, Marcy. All right, computer plate processing chemicals. Now, that's primarily with a litho process, and typically that's going to be a yes, because the pH on that chemistry, and check your SDSs for those, if it's greater than 12.5 or less than 2. Now, in the case of our CTP chemistry, the pH is going to be very high. In many instances, it can be 13.5, and we know the pH scale only goes to 14. And that's going to be a hazardous waste because of the really high pH, and it's going to carry a waste code of D002. Likewise, if I have any waste acids, like a waste battery acid or alkaline cleaners, depending upon their pH, then that's going to be on the lower end. That pH of less than 2, that's going to go off-site as a corrosive hazardous waste as well. Now, waste film fixer or direct-to-plate silver halide chemistry being off-site, sending off-site, if it contains silver greater than 5 parts per million, which many times it does, that's going to be considered a hazardous waste. And I know our industry has made a significant change and moved away from a lot of film processing. In fact, it's hard to find anybody still doing film processing in our industry. But for some of the very smaller printers that are using paper plates, for example, paper plates can be a silver halide chemistry, and that chemistry coming off that plate processor can contain more than 5 ppm silver. So if you're sending it off-site for disposal, that's going to be considered a hazardous waste. Parts washers depends upon the solvent, quite frankly. Some of the regulations that have come in place from an air pollution side have dramatically lowered the VOC content of parts washing fluid, and that has in kind has reduced the flash point. But if you still have traditional parts washers and you're not in an area where you have to meet a specific regulation, if the flash point's below 140 degrees Fahrenheit, that's going to carry a D001. Now, there's one particular vendor that we've run across that also uses a waste code of D039, which I believe is for perchloroethylene. And basically, they're saying that because that parts washing solution gets recovered and reused, it could be contaminated with a chlorinated material. So again, you want to make sure you check the SDS, make sure that the manifest is accurately depicting the waste codes for that parts washer. Now, waste oil that's uncontaminated, as we talked about in the first session, isn't considered hazardous waste. Again, it must be properly managed. And we talked about having the labels and closed covers and things like that. Aerosol cans. Now, here's what's interesting about aerosol cans, and this is probably one of the waste streams that most folks overlook. Empty aerosol cans, those which have been emptied through conventional means, is not considered a hazardous waste. And basically that means if I have an aerosol can where I've used all the contents and I literally can shake that can and hear nothing swashing around inside of it, it's going to be a non-hazardous waste. However, if I have a full aerosol can or a partially full aerosol can, say for example the tip breaks off and I can't use a replacement, it's no longer useful to me, that full aerosol can or an aerosol can with contents is actually going to be a hazardous waste. It needs to be treated as a hazardous waste. And typically it's going to be D001 because the flash point's going to be below 140, primarily because of either the ingredients or the propellant. Next slide, please. Adhesives, hot melt, water-based, PUR adhesives, no, they're not hazardous waste because they don't contain anything in it that's going to be listed and they don't exhibit a characteristic. Solvent-based adhesives, on the other hand, could be considered a hazardous waste because the flash point's below 140. And you'll see a common theme in here. The flash point of 140 is a key number with respect to any solvent-based material. Have flash points of 140, less than 140 degrees, those are going to be considered an ignitable or D001 hazardous waste. Fluorescent lamps, as we talked about in the last session, UV curing lamps or other mercury-containing bulbs or devices, typically they're going to be hazardous waste if you dispose of them, but because the regulations are set up, they encourage businesses and industry to recycle them. They're considered a universal waste, which is much less requirements. You have requirements you must meet, but there are a lot less than them being considered a hazardous waste. CRT screens, if you still have any of those laying around, the old CRT screens, basically, if you throw them away, they're hazardous due to lead content, but if you recycle them, they're actually not even considered a solid waste, and therefore they wouldn't be a hazardous waste. And batteries, a wide variety of batteries that we use in our operation, lead acid batteries, lithium, NiCad, etc. Again, hazardous if you dispose of them, but if you recycle them, they're basically considered a universal waste and you have to follow the requirements for universal waste, but not a hazardous waste. Next slide, please, Marcy. Okay, problems with vendors. Okay, so here's a couple key points you need to keep in mind. First and foremost, do not rely entirely upon your waste disposal company. And I know that's a powerful statement to make, because what happens is that we assume that these guys know what they're doing. They do this for a living, and we can rely upon them for their guidance and assistance. Yes, for sure. But because you're the generator, it's your responsibility to make sure that your waste determinations are accurate, because you, the generator, sign the manifest confirming the information is correct, and you, the generator, actually pay fines, not the vendor. And a waste disposal company, most importantly, may not know much about your process and may list materials as characteristic or listed hazardous waste, and they're really not. So the quick story on this is that we just recently resolved a case with our member who relied upon their waste vendor to make determinations on two particular waste streams. And we'll talk about the primary one was computer-to-plate waste. The computer-to-plate waste, this is when a litho operation, the SDS indicated the pH was exactly at 12.5. So when the waste vendor came in to do the characterization of the waste stream, because this particular facility can't discharge their couldn't discharge their CTP waste to the city sewer because they were in a septic system. So they had to collect that material, they'd collect their waste fountain solution and send it off-site for disposal. The disposal company looked at the SDS, as they would typically do, and say, oh, yeah, pH 12.5, that's a corrosive hazardous waste. It gets the waste code D002. What they don't realize is that as we use our computer-to-plate chemistry, believe it or not, the pH actually comes down because of the developer and the finisher that's in there, because that finisher has a little bit of a lower pH. So when the two mix together, when the plate's processed and the chemistry is spent, the pH can actually be lower. So what happened is, because of COVID-19, our member had been shipping their drums of collected CTP chemistry offsite as a corrosive hazardous waste. Because of COVID-19, what happened is that the vendor said, you know, we can't make it out. We don't have enough personnel. We're going to have to pick up your waste on the next cycle. So when they came out for the following cycle, the printer had twice the amount of waste that they typically send out. That got identified on the manifest correctly. In the manifest, of course, the state always gets a copy of the manifest. It went into the state and it got flagged because it said, oh my gosh, look at all this hazardous waste that this facility just shipped out. And they were identified as a very small quantity generator, and now they're a small quantity generator. And it also happens if you're a small quantity generator, you can get bumped up to a large quantity generator. And so therefore that triggered an inspection. And so when the inspector came out, they wanted to know, well, what happened? Why, you know, what were the circumstances? Why did you have such a large shipment of waste? And by the way, are you doing all the requirements you need to be doing as a small quantity generator? And obviously they weren't, because they're a very small quantity generator. And due to no circumstances that they were under control, they now find themselves in a situation where now they're under an inspection, and that started a whole series of back and forth with the state. And so as it turned out, and then when I got involved, I was like, well, let's measure the pH of the CTP waste. And we measured the pH of the CTP waste. It was actually about 11.5. It was about one. It was actually 1 pH unit down lower than what the SDS had said, and therefore that material was not a hazardous waste. However, because the facility had identified it as a hazardous waste, had shipped it out on their manifest as a hazardous waste, the state took the position, correctly so, that you called it a hazardous waste and therefore it is a hazardous waste. And so that's where, doing the additional testing. And what we were able to do is through our positive efforts and doing the retesting, we literally got a letter on Monday back from the state where we thought, and I thought, that they were going to receive a notice of violation. And the letter indicated that they noticed a lot of violations because they weren't doing the things that they had to be doing. But they said because of the positive actions taken by the company to reclassify the waste, the state considered the case closed and they weren't going to penalize the company for doing that. And so that was an excellent outcome. Now, I can't say that we always have that outcome when a situation like this happens, but this is a great example as to not rely completely upon your waste disposal company for the determination of whether your material is considered hazardous or not. You want to work with them. And in some cases, you may have to do testing, as we said here. The SDS indicated pH of 12.5. They did the testing and showed that the pH was actually lower than 12.5, so therefore it wasn't a hazardous waste. And the other waste stream was on recovered fountain solution. And I wouldn't have time to get into the story on that one, but also the same situation. That fountain solution was classified as a hazardous waste when we did the testing, the flashpoint testing, which I knew was going to turn out to be much greater than 140. That's how it turned out, and therefore that waste stream, which was being sent off-site as a hazardous waste, was not considered a hazardous waste. And so the moral of the story is that it was a very tense situation for a period of, and believe this, it went on for several months because there was a lot of back and forth, a lot of correspondence with the state on trying to get this situation clarified and squared away. But I'm glad to say that it turned out to be a good story. So that's my story. I'm going to turn it over to Mike at this point. And Marcy, next slide, please.
Thanks, Gary. So, wow, what a great way to end that part of the presentation. And now I'm going to turn it over to Mike Ellenbecker to talk to us about waste determinations as well as land disposal restrictions. Mike?
Thanks, Marcy and Gary. So I'm going to be, as Marcy said, I'll be talking about the waste determinations and land disposal restrictions, or LDRs for short. And basically, there's 10 steps to a waste determination, and we're going to go through each one of them, kind of a little bit in detail to show you how all this comes together to make the final waste determination. We do have on our website a waste determination guidance document. It's WA 1152. If you go to the Wisconsin DNR website and then just type in under the search button or field, which is located in the upper right-hand corner, hazardous waste resources. It will take you to our resource page and click on the WA 1152, and then you can download that and take a look at that. Next slide, Marcy, please. So on September 1st of this year, Wisconsin promulgated new rules for hazardous waste management. And some of those rules affected the way we do waste determinations. So one thing is that it specifically states now that waste determinations must be accurate. It also states that waste determinations must be made at the point of generation. And then the code goes into some detail now on how to make a hazardous waste determination for both the listed and the characteristic hazardous waste. And then the code talks about possible exclusions or exemptions. And then it moved the record keeping requirements into the waste determination requirements. And then it now requires SQGs and LQGs that prior to shipping your hazardous waste offsite, that they need to put all applicable waste codes on that container. Next slide, Marcy. So this is cut out from our waste determination document that I had discussed earlier. And basically there's really 4 big steps to making a hazardous waste determination. The first step is it a solid waste? The next one, is that solid waste excluded from regulation? And then is that solid waste a listed waste? And is that solid waste also a characteristic waste? And then of course you need to document this determination. Next slide, please. So is it a solid waste? So 662.011 is where we find the requirements on how to do a waste determination. And one of the first parts of it, a person who generates a solid waste must make an accurate determination. So, next slide, Marcy. So what is a solid waste? So when we talk about a solid waste, we're not referring to the physical state of the material. A solid waste could be, it could be a solid material, it could be a liquid material, or it could be a contained gaseous material. In addition, solid waste is not excluded under 661, nor has been granted a variance or a non-waste determination under 660. And I am not aware of, in Wisconsin, of any facility been granting a variance or a non-waste determination. So if you have a solid waste, then if that material is discarded, and what is discarded, it means it's abandoned, and abandoned can consist of being disposed of. It could be burned or incinerated, or it could be simply accumulated in lieu of being abandoned or disposed of. And what that is meaning is you just can't simply store something for the purposes of trying not to abandon it, even though it is a solid waste. In addition, discarded is when you recycle something. So if you're recycling your solvents on site, that would fall under the definition of discarded material. Some materials are inherently waste-like. These are your dioxin-bearing wastes. And then, of course, or last, the military munition is also considered a discarded material. Next slide, please. So in our 661, there is a table that we use to determine, to help us to determine when a material is a solid waste. And on the left-hand side, you have the spent materials, you have sludges, both listed and characteristic. You got byproducts listed and characteristic. You have commercial chemical products, and you have scrap metal. And then on the top side, you have how this disposal is occurring. Use constituting disposal, being used to recover energy, being reclaimed, or speculatively accumulate. And based on what I know of printing facilities, probably the two most common things are going to be spent materials. These would be your spent solvents, your waste inks, and then your commercial chemical products. And these would be, a good example would be inks that have never been used, like a drum or a container of ink, that maybe is past the manufacturing date or it's off spec or something. That's an example of a commercial chemical product, and we'll talk about that later on. So as you can see in this table, most of the stuff with a star is considered a solid waste. However, there's a few things that when you're recycling or speculative accumulation, those things would not be considered a solid waste. Next slide, please, Marcy. So the waste determination must be accurate. So that is specifically stated now in the new requirements. Next slide, please. So how do we make an accurate waste determination? There's two ways we can do this. We can use knowledge, what's kind of referred to as generated knowledge, or we can test a representative sample. So when we have a listed waste, you have to use generator knowledge to make that determination. You have to know the source in order to determine if something is a listed hazardous waste. And you have to use what we call acceptable knowledge. And what is acceptable knowledge? Next slide, please, Marcy. So acceptable knowledge is based on reliant and relevant information. For example, if the department comes in and they do an inspection and they say, is this material a hazardous waste? And you say no because so-and-so said it was not. That would not be reliable information or relevant information. It doesn't meet that situation. However, you say, well, here's the safety data sheet. It shows that the flash point is 200 degrees and it's way above 140. So no, it's not a hazardous waste. So that would be safety data sheet can be used as acceptable knowledge. Next slide, please. So other things of acceptable knowledge include process knowledge, which describes the information about chemical feedstocks and other inputs into the production process, knowledge of products and byproducts, chemical or physical characterization of the waste, information on the chemical and physical properties of the chemicals used, and testing that illustrates the properties of the waste. So these are all examples of what can constitute acceptable knowledge. Another example is, Gary had presented earlier kind of the common waste for industry. So you would not be able to use that as acceptable knowledge from this presentation to show that a material is not a hazardous waste. Next slide, please. One time, what we see when we go to inspections is a lot of times we ask for a waste determination and the facility submits to us a waste profile. And the waste profile in of itself is not truly a waste determination. A waste profile is basically used by the TSD facility to kind of categorize the waste coming in. Here are some issues with waste profile. So this is a kind of a typical waste profile. They checked it as a liquid. They checked it off as 10,000 BTU. They said the pH is 4.1 to 10. So taking a look at this as I was reviewing this, I would have some concerns if they were using this for waste determination. For the physical state, that's something that can be easily verified for liquid. They checked 10,000 BTUs. How are they getting this information? How do they know it's 10,000 BTUs? Is it just something they're thinking it's about 10,000 BTUs? Or is there information from testing or a safety data sheet or something else that shows that it's 10,000 BTUs? Another concern is that the pH is between 4.1 and 10, and this appears to be a D001 because it's a high BTU value. And typically to have a pH, it needs to be an aqueous solution, and typically you don't have aqueous solvent solutions. Next slide, please. Again, this is the same kind of waste profile. They put down 0 part per million for their metals. How do we know it's 0 part per million? What information can they supply to us to show that they know it's 0 part per million? Do they have the testing? Is it based on safety data sheets or something else? So kind of to reemphasize, waste profiles in and of themselves are not waste determinations. They're kind of a subset, and they're basically used by the TSD facility to categorize the waste coming into the facility. Next slide, please, Marcy. So we talked about using generator knowledge for making waste determination, and that is acceptable, and that's what a lot of people do is use generator knowledge. But again, it has to be acceptable knowledge. You have to be able to demonstrate that it is or is not that. And a lot of times we'll take a closer look at something when a generator says it is not a solid, it's not a hazardous waste, then it is a hazardous waste. Because if you're saying it's not a hazardous waste, there could be a potential to mismanagement. It's better off to have a hazardous waste, or I should say, it's better off to have a non-hazardous waste overmanaged than to have a hazardous waste undermanaged, that is, go into the dumpster. So the other part of making a waste determination is testing. And for testing a characteristic waste, it requires a representative sample. And basically, when we talk about a representative sample, every individual in that population has an equal chance of being sampled. So we go out to do inspection, and the generator said, yeah, we took 3 samples from the drum. And then we asked, well, how did you pull those samples? And we just took them off the top of the drum. And that would not be an example of a representative sample. Even though all the testing was done, it was all done correctly, the very first part of collecting a representative sample was not done. And just to give you an idea of how hard a representative sample can be, or that it requires some thought, is imagine you have a bag of 1,000 marbles. And within that bag, there are 900 black marbles and 100 white marbles. And if you wanted to know the composition of the marbles in that bag, the question I ask you is, what is the minimum number of marbles you'd have to pull from that bag to show its true composition. And the answer would be 10, assuming you pull 9 black marbles and 1 white marble. But the odds of pulling 9 black marbles and 1 white marble from 10 grabs in the bag is fairly small. So you want to pull maybe 30 or 40 marbles out of that bag and use that as your sample. The more grabs you have, the better you are able to represent that population. And that's the same thing we want to do with a waist determination. Is in this drum, we just want to take it from the top, we want to take it from the middle, we want to take it from the bottom, we want to take it from all over. And we want to take enough grabs to make sure that we can represent what's in that drum. And we're not going to send off each grab for analysis. That would be extremely cost prohibitive. What you do is each grab may be a tablespoon in size. Each tablespoon is put into one container, and then that container goes off as, you know, one sample to the lab. This type of sampling is cost effective. It's, as a term, it's called incremental sampling methodology, or ISM, and you can kind of Google that to get a better understanding of representative sampling. And that that type of sampling is great for doing with solids. In the case of liquids, you can use what we call a Kalawasa sampler, which is basically a glass tube that you can plug. And the way the Kalawasa sampler works is you insert it into the top of the drum, you push it down slowly, and then as it goes down, it basically collects the liquid in the drum, and then you plug it at the bottom, bring it up, and then you dump it into your sample container, and now you got your representative sample. Next slide, please. So we talk about having a accurate waste determination, and when EPA talks about an accurate waste determination, as we stated earlier, it is okay to overclassify something as a hazardous waste when in fact it really is a non-hazardous waste. So that's fine from a regulatory standpoint, but I would encourage facilities to truly make an accurate waste determination to truly determine whether it is a hazardous waste or not. Next slide, please, Marcy. So the code now specifically states that the waste determination must be made at the point of generation. Next slide, please. So what is the point of generation? So examples would be when a solvent can no longer be used for cleaning. So at that point, that is the point of generation. The solvent becomes discarded, even though it's being recycled, maybe on site. That is the point of generation for that solvent that can no longer be used for cleaning. Other examples is when you remove the still bottoms from a distillation unit. That is a point of generation. Ash generated by an incinerator, that's another point of generation. We talked about earlier commercial chemical products. So inks, you may have in your storage room various inks, and at some point in time you're going to decide, well, maybe I can't use this ink because the color's out of fashion, or perhaps it's past the manufacture date, or maybe there's a recall on that. So for commercial chemical products, it's when you decide basically that this material it has to be disposed of. So you could have a product that is past its expiration date, but you think it's still usable, and that's perfectly fine. But it's until you make a decision to discard that commercial chemical product, then it becomes a waste. Another thing is manufacturing process units like printing presses. So if you got waste that's in the manufacturing process unit, you have 90 days to have it removed from the process or the printer when that thing is taken out of service. And then another example would be a lamp that's removed from a fixture for disposal or recycling. Next slide, Marcy. So one of the things you need to do is determine if the solid waste is excluded. And there's two parts to that. Is the solid waste excluded from being a solid waste, or is the solid waste excluded from being a hazardous waste? Next slide, please. So examples of materials that are not solid waste are like domestic sewage exclusion. So if you put something down in a sanitary sewer and when it mixes with the domestic sewage, that hazardous waste is no longer regulated under RCRA. Gary talked about CRTs, cathode ray tubes. So CRTs that are recycled, and when the generator follows those conditions of exclusion, they're not considered a solid waste. And again, there's probably like 5 or 6 conditions of exclusions for CRTs. You have to follow each and every one of them. Failure to follow one of them results in the CRT being a solid waste and therefore a hazardous waste. HSM, hazardous secondary materials that are being recycled, legitimately recycled, are not solid waste. Scrap metal that's being recycled is not solid waste. And if it's not a solid waste, it can't be a hazardous waste. Then there's the other part where solid waste, it's a solid waste, but it's not a hazardous waste. And a good example is household hazardous waste, universal waste batteries and lamps. Analytical samples, these are examples of solid waste that when managed under the conditions of exclusions are not a hazardous waste. Next slide, please. So we talked about, is it a solid waste? Making an accurate waste determination, determining if it's excluded. And now we need to determine, if we get all through that, is this solid waste a listed hazardous waste? And we talked about earlier, to make a listed hazardous waste determination, you must know the source. Now, testing alone will not determine if you have a listed hazardous waste. It has to be based on generator knowledge. Next slide, please. So listed hazardous wastes are broken into the 4 categories. There's the F-listed waste, the K-listed waste, and the U and P-listed hazardous waste. And the U and P-listed wastes are basically your commercial chemical products. And for the printing industry, you're going to have some F-listed hazardous waste, basically something from F001 through F005 regarding spent solvents. And basically, your F-listed hazardous waste are hazardous waste generated from non-specific sources. Next slide, please. So there's 2 common probably listed hazardous waste in the printing industry. And basically, it's going to be F003 or F005. And these are your non-halogenated solvents. So for F003, these non-halogenated solvents consist of xylene, acetone, ethyl acetate, ethyl benzene, and so on. And for the F005, these non-halogenated solvents consist of toluene, MEK or methyl ethyl ketone, carbon disulfide, and so on. You will notice on the right-hand side, there's a hazard code. F003 is a listed hazardous waste solely because of its ignitability. That is, it has a flash point of less than 140 degrees Fahrenheit. F005, you'll see it has an I and a T. So F005 is listed for ignitability and also for toxicity. It's poisonous. In addition to the solvents, it has to be a particular blend of solvents. And that's what I have highlighted here. So it's all spent solvent mixtures or blends containing, before use, 1 or more of these non-halogenated solvents and a total of 10% or more by volume or 1 or more solvents listed in F001, 2, 4, and 5. And it's very similar to the F005. Next slide, please. So reading through that can be a bit confusing. I have in this here kind of a flow chart that can help you walk through the process to determine if your particular blend of solvent is an F003 or 5. Next slide, please. So here are some examples of the solvent mixture for F005. So you can see, like, if you have 80% acetone, 20% xylene, that is an F03 in addition to being a D001. But if you had like 70% acetone and 30% petroleum distillates, it's just a D001. Next slide, please. The next group of hazardous waste are your K-listed hazardous waste. There are, from a printing standpoint, there are no K-listed hazardous waste. These are K-listed hazardous waste are from very specific industry sources. Next slide, please. And then we talked about a little about commercial chemical products. These are your P and U listed hazardous waste. It is important that commercial chemical products, the P and U listed hazardous waste, they're unused and discarded commercial chemical products. They would never be spent. So if you had a drum of acetone that you no longer needed, it would not be an F003. It would be a U002 because it was never spent. The P hazardous wastes are what we call our acute hazardous waste. And these are hazardous wastes that are extremely toxic. Typically, to be a large quantity generator, you have to generate 1,000 kilograms or 2,205 pounds in a calendar month. However, with acute hazardous waste, it only takes 2.2 pounds or 1 kilogram in a calendar month to make you a large quantity generator. Next slide, please. One thing to note is when we talk about listed hazardous waste, there's what we call the mixture and derived from rule. So a lot of times you'll probably be more subject to the mixture rule than the derived from rule, but the mixture rule basically states that if you take a listed hazardous waste and mix it in with other hazardous waste, the whole hazardous waste, it's now all hazardous waste. So you had some F005, let's say you had a dropper of it, you put it into a tanker truck, you now have 6,000 gallons of listed hazardous waste. So it's important to understand the mixture rule to avoid having other stuff being classified as hazardous waste because you mix something in with it. Next slide, please. So you determine that you have a listed waste, but you also must determine if you have a characteristic waste. You just don't stop if you have a listed hazardous waste. And you can kind of see all the detail that goes into making a characteristic waste determination. So next slide, please. So a characteristic waste, there are basically 4 categories. You have your ignitables, the D001, your corrosives, your D002, your reactives, the D003, and then your toxics, the D004 to D043. These are TCLP constituents, toxic characteristic leaching procedure constituents. Next slide, please. So what is an ignitable liquid? Basically, you got to have 3 things. First of all, it has to be a liquid, and it's not an aqueous solution containing less than 24% alcohol by volume, and it has to have a flash point of less than 140 degrees Fahrenheit. And examples of this would be xylene, toluene, acetone, benzene. These are all liquids. They don't contain these alcohols, and they flash way below 140. Next slide, please. You can also have an ignitable non-liquid or solid. There is really no test method for these. It's basically your best professional judgment. If you had something like an air filter that kind of burned in your dumpster, that would probably be a strong indication that you have a flammable solid. Next slide, please. Another ignitable are your flammable gases that are containerized that meet DOT's definition of a Division 2.1 flammable gas. So examples would be like propane, acetylene, butane, hydrogen. Next slide, please. And then finally, the last category of ignitables are oxidizers, your DOT oxidizers. And again, you look at DOT's hazardous materials table in 49 CFR 172.101 to determine if you have a DOT oxidizer. So nitric acid in concentration from 65 to 70% are considered oxidizers. Next slide, please. Corrosive, these are your D002 waste. So they either have a pH of, if they're an aqueous solution, they have a pH of 2 or less or a pH of 12.5 or greater. And battery acid, sodium hydroxide, nitric acid, these are examples of aqueous solutions with high or low pHs. Or it could be a liquid that is capable of corroding steel at a rate of 1/4 inch per year. An example of that would be ferric chloride. Next slide, please. And then the reactive waste, D003, Again, there's no specific test method. Reactive waste are capable of generating a toxic gas between a pH of 2 or 12.5, or they're capable of a detonation or explosion. Lithium sulfur batteries, formulations of nitroglycerin, ethylene oxide, these are examples of D003. Again, there's no test method. You got to use your your best professional judgment to determine if you got a D003. Next slide, please. And then there's the toxic characteristic leaching procedure, the TCLP list. So the TCLP was designed to simulate how waste would leach in a landfill. And there's 39 chemicals on it. And it's done by a test called a TCLP extraction test. And basically, when we talk about TCLP, the TCLP extraction is a percentage of the totals. So let's say you had a sample that had a total metal concentration of 10,000 part per million. The TCLP test would be less than or equal to 10,000. A lot of times it's way less than. So if you had a solid, say had 10,000 part per million, the TCLP test could be 500 part per million, or it could be 1 part per million. It depends on the type of a solid you have. Next slide, please. The TCLP list is basically broken up to 4 areas. You have your heavy metals. So this would consist of arsenic, barium, cadmium, chrome, lead, mercury, selenium, and silver. And it sounds like in the printing industry, you may have bariums in your ink. And if you got photographs, you may have silver fixture. And then you can see the level. So for barium to be a hazardous waste, it's 100 milligrams per liter. And that milligrams per liter indicates that it's the result of a TCLP test. If it's kilograms, then that's indication of totals. Next slide, please. You have your volatile organics like benzene and chlorobenzene, tetrachloroethylene, vinyl chloride. Next slide, please. You have your semi-volatiles like the creosoles. Next slide, please. And then finally, you have your pesticides like endane, lindane, 2,4-D. And these are all the TCLP constituents. Next slide, please. So kind of getting towards the end of the waste determination process, you need to keep records of your waste determination. And typically, these records need to be maintained for at least 3 years from the date that the waste was last sent to either an on-site or off-site treatment, storage, or disposal facility. Next slide, please. So again, we talked about maintaining them for 3 years. The 3-year period is automatically extended if you're in an enforcement situation. Next slide, please. So the waste determination records, they need to include the following types of information. So if you have any test results, you need to include those. How the waste was generated, the composition of the waste, and the properties of the waste. So if you're using generator knowledge, you need to explain the basis for that generator knowledge. And you should keep these records organized and readily acceptable so that when you do an inspection, they're available for the inspector in a short amount of time. Next one. Thank you. And then identify all applicable EPA hazardous waste numbers. So next slide, please. So prior to shipping the waste off-site, you need to put all the EPA ID numbers on that container. Those numbers are not required to be on site while you're accumulating them. However, I would strongly encourage that you have those numbers on the drum as they're being accumulated. But they must be on the drum when they're ready to go over the road for to the TSD facility. Next slide, please. So the last part of the presentation are the land disposal restriction requirements, or LDRs. And basically, for the most part, these are record-keeping requirements for generators. Next slide, please. So who needs to comply with the LDRs? TSD facilities, yes. Large quantity generators, small quantity generators, yes. VSQGs are not subject to the LDRs as long as they follow their conditions for exemptions. So as long as they follow all the rules, they're not subject to the LDRs. I would strongly encourage you that when you do your hazardous waste determination, that you also do your LDR requirements. And LDR treatment standards only apply to waste that are hazardous waste at the point of generation. Next slide, please. If you generate a characteristic hazardous waste, you need to identify the UHCs, the underlying hazardous constituents. One thing to note is that the UHCs are not applicable to what we call a D001 high TOC waste, which is basically if you have a spent solvent going off site, typically spent solvents are going to be a high TOC waste. You do not need to identify the UHCs. Next slide, please. And then we talk about record keeping requirements. Basically, for stuff that is going off site, hazardous waste going off site, that initial shipment to that particular TSD facility requires an LDR document. And that LDR document not only goes with the TSD facility, but it also needs to go in your file. And I would encourage you to keep your LDR documents in with your waste determination documents. If you send that same hazardous waste to a different TSD facility, that different TSD facility will require an LDR notification form, and you need to place an LDR notification form for that TSD facility in your file. In addition, we talked about earlier in the waste determination process that you may have a solid waste that becomes exempt or a hazardous waste that is exempt from being a hazardous waste. If you have that type of waste, then you need to keep on site a one-time on-site notification for LDR in the file. And next slide, please. And that ends my part of the presentation.
Wow, thanks, Mike. Wow, what a lot of information just to absorb. I'm really glad that we are recording this and that others will be able to really digest this. So Joe, just checking in, do you have any questions for us?
Absolutely. Thank you, Marcy, and thank you, Mike and Gary. I have a few questions. Question for Gary: what is the most common hazardous waste generated by a printing operation? Gary, you with us?
Yes, I think he needs to unmute.
Gary, could you unmute? Well, I have one for Mike. We'll come back to Gary.
Can you hear me now?
Oh, yes, please.
You're back. Okay.
Okay, yeah, so I was muted. I think I was double muted. So, yeah, I think that's a great question. You know, the most common hazardous waste stream generated by printing operations obviously is going to be based on the type of printing or the dominant type of printing process that you're using. But I would say overall, usually cleaning solvents are probably the most common one that printing operations generate. And depending upon, you know, if you can discharge, Mike had mentioned, you know, being able to discharge materials to the sewer with permission from the sewer authority. You just can't dump stuff down the drain. We mentioned that in the first one. You have to have permission from the sewer authority, but some materials can be discharged to the sewer. So if you're not doing that, then perhaps some of the corrosive waste would also be the second most common.
Excellent. Thank you, Gary. I have a question for Mike. What is the best way to determine if my waste is hazardous?
The best way? Well, one, make sure you follow the steps that are outlined in 662.011, because that will walk you through everything. If you are unsure, you can always, you know, contact the department and they can help you. But understand that the waste determination is a generator responsibility. We can provide input, but ultimately, if things go wrong, you are responsible for making a proper waste determination. And you can also hire a consultant too, but again, make sure that you do that waste determination properly and if you don't know how to do it, reach out to a consultant or the department, they can assist you.
And I will add, and I also encourage everyone to listen to the first presentation in this series, because Amy actually walked through the participants where on the Wisconsin DNR website you can find all of this information. Because we have worked really hard with the Wisconsin DNR to develop and establish really great resources. And I know Mike has established some really great resources on how to make a waste determination that are actually fairly simple, and well, not simple, that's a misunderstanding, but very easy to follow. Let's put it that way.
I do have a follow-up to the last question, Mike. So once you determine, hey, material's hazardous, do you have to test it each time to make sure it's hazardous so it meets that particular threshold?
When you have to, the only time you basically reevaluate waste determination is when the process or the input materials have changed. Then you absolutely must reevaluate. But as a rule of thumb, maybe every 3 years, take a look at all your waste determinations and make sure that they're accurate and correct.
Excellent. I appreciate it. Are there any other questions? I've answered.
Yeah, Joe, I just wanted to add a little bit to the discussion, because those were good questions in terms of determining whether you have material to hazardous waste or not. I know Mike had mentioned that. I think, Mike, if you could reiterate again, isn't there a fact sheet that the DNR has that walks you through this process?
Yes. Give me a second here. I'll give you the WA number.
Yeah. And I think, from
WA 1152.
Yeah, and I think that'll walk you through the steps on the hazardous waste determination. But I think basic things that you need to be aware of and basic information you need to have available to you when you make a determination is, of course, it's a combination, as Mike had mentioned, of process knowledge or testing. So, going back to my example that we had with our member that we resolved in a positive fashion, I'm not sure they were aware of the process knowledge part of it, that the CTP chemistry pH can actually come down as you use that chemistry, or once that chemistry is considered spent. So that's good to know that as well. But looking at, collecting your SDSs, collecting information from the manufacturer, labels on the containers will give you a lot of indications regarding contents and concentrations of materials. And in some cases, you may have to test, and in not all instances, but in some cases it's worthwhile, conducting some tests on flash points and perhaps pH. I mean, the most common waste streams, as I said, we generate typically are going to be a solvent-based, or maybe the better way to say that would be ignitable. The D001s are pretty common, and then corrosives can be common depending upon where your waste materials go. So in those two instances, unless it's very clear, so for example, cleaning solvents that would be mixed with some ink waste from cleaning up, I think you can pretty much assume the flash point is going to be what's on the SDS. But if you have a high ratio of ink to solvent, it might be worth running a flash point test. And likewise for corrosive material, if you think that perhaps the pH has been changed as a result of using the chemistry from the SDS, because the SDS, remember, the SDS represents the material in an unused form. And when we're dealing with a waste, we have it in a used form. So sometimes it translates easily, sometimes it doesn't. So it does require, a process where you apply the logic that's in the fact sheet that the DNR has, as well as the knowledge that you have about how you utilize that chemistry.
Hey, Gary, just to add to that, making a correct waste determination is important, because it kind of prevents you from mismanaging material. So if you make a correct waste determination, make an accurate waste determination, you're basically not taking a hazardous waste and tossing it in the garbage, which causes a whole bunch of problems down the road. It's right. Kind of the first step to make sure that everything is properly managed. Mm-hmm. And then just kind of to add to that is that there are exclusions and exemptions within from something being a hazardous waste. If you're using the exclusion or exemption, be sure that you understand how that exclusion or exemption works, because failure to follow all parts of that results in material being as a hazardous waste. So it kind of creates a high degree of understanding of how these things work.
Yeah, that's
Great.
an excellent point. Yep.
Right. Any other questions, Joe?
No, I was going to open it up to make sure that everybody has an opportunity to ask questions. If there's any questions, please ask now.
And while Joe's collecting those, I have put the contact information for Mike and Gary up on the screen. Again, the slides and the recording will be sent out to everyone who participated, and we thank you. And just before we check with Joe one last time before we end, I do want to put up on the screen our next webinars. So we have 4 more. The next one will be starting off the new year with the generator status and episodic generation. And Gary and I are quite excited about the new requirements under episodic generation because it does provide printers with the opportunity when you are looking to do a bit of house cleaning, you do have the opportunity to actually remove it carefully and safely out of your facility. And then we will look at management, transport, and reporting, inspections and record keeping, and tanks, exemptions, and hazardous secondary materials. So we encourage you, again, you can find all these webinar programs posted on Joe's site at gelga.net. I think I'm right there.
Info.
Excellent. And the registration is free and open, and we just encourage you to sign up so that you can further your knowledge on the changes that have occurred within the hazardous waste regulatory framework. And one last call for questions, Joe?
No extra questions.
Okay, great. Thank you, everyone. And this concludes our program today.